Good morning. My name is Mark Brown. I'll be your instructor this week. So this week we're talking about doing some debugging in theory, not so much actual practical applications of it. That's actually going to come next week. We're going to bring in some broken code and work through it. But for right now, we're just going to talk about some approaches you guys should have when you're actually doing debugging and what to do whenever you try to work around your program and it just doesn't quite work. So what we're going to be doing today here, we have three things we're going to talk about. First of all, we're going to do a bit of myth busting and talk about some preconceived notions people have about debugging, ideas and thoughts they have about it that don't end up being quite right. Next thing we're going to talk about is prevention, how to actually stop having bugs before they actually occur, things to do ahead of time. And finally, we're going to talk about, okay, we have our program, we're trying to run it, it's just not working. How do we approach figuring out how to fix it? So some debugging myths. So the first myth, all bugs are fixed in a program by launch. That is never true. There's always going to be some bugs in any game, any program, anything you look into. There's an entire speedrunning community built around exploiting these bugs that are in these games. So it's a case that you have to kind of learn how to triage these bugs. What is actually important, what is not. Does it really matter if the character has a weird half-second glitch in 50 frames in on his animation, or is that more important than the game actually crashing? So you have to go through and to decide what is important and which are the ones you have to fix in the industry when you're actually working on them. A second problem people have is they have their program running, they compile it, and they're like, okay, hardest part's done. We got all those errors out of the way. That's never really the case. Whenever you have crashes and whenever you have errors showing up in your compiler, those are the easy bugs to fix because it points you right to where it is. You can go there and you look at it and you figure it out. 9 times out of 10, the actual warning itself or error itself tells you what the problem is. Null exception errors, stuff along those lines. So it's very easy to fix those bugs. It's the bugs that are actually in the code that's the issue of logic. The logic just doesn't quite work out right. And you don't really see it in the compiler. It's when you actually run the program. Those are the ones that are the hardest to find. Those are the ones that are the hardest to fix. And finally, it's just a warning. It doesn't really matter. This one is absolutely false. Whenever you see warnings in your program, that means something is not right. It doesn't mean it's not going to run. It just says something here is not right. And the big problem that you have is these warnings can actually hide other errors, other issues you're not seeing. So it'd be like warning about a variable that's being declared but not used. That can have a much bigger impact because your actual logic is relying on that variable to be used, and you're not actually using it. So I always treat warnings as errors. See what this warning is, fix it as soon as you can so it's not there hiding something else. So now some prevention. What are things that you can actually do to avoid having these bugs in your code to begin with? Well, the first thing is plan ahead. A lot of times I'll talk to people and they want to just immediately start coding. You're excited to get started. So they immediately just walk up there and immediately set down the computer and just start type. The problem with this is you don't really have a plan. You're not really figured out what it is you want to do. What I recommend is you set down the pencil and paper, old Mark I pencil and paper. And you scribble out a kind of a rough pseudocode, what it is you want to do. And when you do that, you understand the logic. You'll know what it is that you're actually wanting to do step by step by step. Then when you sit down at the computer and you start typing away, you have a plan, you have a route, you have a goal as you're working towards it. So if you do all this stuff here, it's not going to have this case of what's going on, I don't understand my own code. Now you understand it ahead of time, you have it written down on paper. When you're putting it on the computer, you're just basically transcribing it from that paper to the computer and making sure it works. Another thing is kind of a plug for the previous lectures. We need to apply the practical paranoias. Membership operators, fines, arrays, but ifs around these things. Check them for null exceptions. When doing this, you're going to prevent yourself from having a lot of bugs in the long run. On top of that, you use the constructive laziness we talked about earlier, where you have actual helper functions do stuff for you. So that whenever you have a problem in your code, you're actually able to say, okay, this is a problem in this specific function that I know exactly where it is. Be able to jump right to that and fix it there as opposed to having to hunt it down in multiple functions in multiple pieces of code throughout the program. So make it so you only have to fix something once instead of 50 times. So we have our program, we've got it all planned out, now we're trying to run it and it's just not working. Something is not working in the program. How do we go about actually fixing that? How do we go about actually finding out what that error issue is? Well, these are not actual techniques that are standalone. They don't actually work just by themselves. It's going to end up being a combination of all of these that works, but I'm going to walk through them step by step. The first one is called wolf fence debugging. And it's based on the idea of you're in the country of Canada. There is a wolf in the country of Canada. You can build a fence. How do you find this wolf in Canada? So the answer is you build a fence down the middle of Canada and you listen for the wolf. And you find out the wolf is on the left side or the right side of that fence. Once you know where that is, you build a fence down the middle of that chunk of Canada. And you keep working, getting smaller and smaller and smaller until you actually find this wolf. So it seems kind of silly in how it actually applies to programming. What you actually are supposed to be doing here is you say, okay, I have an issue here going on. I have a gun that's not firing. I have a character that's not jumping. And I need to determine what is going on and where that error is occurring. So just saying he's not jumping doesn't tell you anything, doesn't tell me anything. But you say, okay, I can put a debug print in, debug log in here, and I can see, okay, it's getting the information saying that the thing has been pressed, the key has been pressed. So it says, okay, everything before that, we can cut that out. That's not where the error is. Things are working up to this point. It's from this point forward that where this error is going to occur. So, okay, he's not actually jumping. So let's look and see the character itself. Let's check the character. Is the character ever getting input? Just keep on doing this progression, chunk by chunk by chunk, reduce the number of areas you have to search. So eventually you have a very small area. You're like, okay, the bug is in here. Let's look at that and figure it out. Now you notice I already mentioned my second item here, print debugging. Use debug log. Use it a lot. You're going to love this. Use it all the time. Debug log you can use to say, okay, something is going on in this area. Let's check these variables. Let's check this, see if it actually is getting here, etc., etc. I like to sometimes just put a debug log inside an if statement. Say, okay, if this works, debug log out. Say, yay, it worked. So I can know this if statement is working. On top of that, the stuff we talked about earlier with the practical paranoias where you put ifs around your nulls to make sure the stuff is not null. What I like to do in the else statement, put a debug log there. And I don't just put a debug log that just has the name. I say the name of the file, the name of the function, and what I'm doing. So that when I see this debug log come out, whenever it's crashing on me, it's not working, I have the information right there available telling me what's going on. So, you cannot use too much debug log. And it's very simple just to comment it out at the end and call it good. Another thing you can do is you're having your code not work is a technique called code grinding. So code grinding is going to be slow. Code grinding is going to be laborious, but code grinding will actually let you find your stuff eventually. What you recommend you do with code grinding is you actually print out a chunk of your code, print it out on paper, then get away from the computer. The classical example is to go down to the cafeteria and drink a whole bunch of caffeine while you're doing this, but find something that you guys want to do, find somewhere that you're comfortable, and actually go through and play the role of the computer. So if the computer tells you to create a variable for int named I, you create a variable named int named high. It says if it says assign I the value of 1, you assign I the value of 1. You work through line by line by line as if you were the computer and find out where this logic is failing and where you're coming up with errors. And finally is a personal favorite of mine called rubber duck debugging. Now rubber duck debugging is based on the concept that as you teach something, you learn more about it. This technique works with teddy bears, dolls, and younger siblings. It doesn't require just have a rubber duck. So what rubber duck debugging actually is, you have a small innocent object sitting there in front of you, and you teach this object what you're doing with your code. So the classic example is the rubber ducky sitting here in front of you looking at you. Debug ducky. So what you do is you walk through step by step and you explain exactly what it is you're doing through this code, going line by line. On this bit of code, I'm checking to see if there's exceptions. On this line of code, I'm doing this. On this line of code, I'm doing that. And as you're explaining to this object or this little sibling, whatever you want to call it, whatever you want to have, you are actually examining it in your mind and determining how the logic works. So as you're going through, you'll feel really silly doing it. I'm not going to lie about that. But as you're doing it, you'll be actually getting some insights into how your code is actually working versus how it's supposed to work. And you'll be able to find these errors like, oh, wait a minute, my logic here does not work because of X. You'll actually be able to fix that and adjust it accordingly. And that's pretty much it for you guys. So again, these are not going to be stuff you're going to do standalone. When you're working through, you're going to have your wolf algorithm, wolf fence algorithm you're working through. You're actually going to also be using debug logs with it. These are things that are always going to have to work hand in hand to get this stuff to actually work. There's no one silver bullet that you do this one thing and all debugging is fine and all debugging is solved. These are techniques, a way to approach it and see how it's going on. So what do we talk about? Well, we talked about some myths that people are common with throughout debugging. People having these opinions about things that are just not quite true. Something we talked about is prevention, things you can do ahead of time so that you don't actually have these bugs occur, period. And finally, when you actually do have these bugs, some ways to actually get around it. Again, we have the wolf fence debug, we have the rubber ducky debugging. And that's pretty much all I got for you. So thank you very much. Have a good day.